On April 6, 2026, 4 astronauts inside NASA's Orion spacecraft swung around the far side of the moon at just over 4,000 miles above the surface. They had a window, they had cameras. For about 7 hours straight, they barely put them down. By the time their 7-hour observation window ended, the Artemis II crew had captured about 10,000 photographs of the moon, the Earth, and views of deep space that no human had ever seen before. And the images they beamed back to Earth stopped people in their scrolls. They trended on every platform. NASA Administrator Jared Isaacman looked at the first batch and said something you almost never hear from the head of a space agency. He called them absolutely stunning, and then added, "This is not AI." But here is what makes these images truly wild. We have only seen a small fraction so far, including the most iconic shots, like the Earthset and the eclipse views. The full archive, including thousands more images and 4K video, is still coming down after splashdown in the Pacific Ocean on April 10th. What we have gotten so far is the preview. Even that preview is already being compared to the most iconic space images in human history. So today we are going through the best Artemis II moon images released so far, the stories behind how they were captured, and why scientists, photographers, and space nerds everywhere are already calling this the most photographically significant space mission since Apollo. But first, some quick context. Artemis II launched on April 1st, 2026 from Kennedy Space Center's Launch Complex 39B. That's the same pad that launched the space shuttle, and this was the first crewed mission to leave low Earth orbit since Apollo 17 in December of 1972. The mission was originally supposed to happen in 2023, then got pushed to 2025, then got pushed again because of heat shield problems discovered after the uncrewed Artemis I flight. Specifically, the ablative heat shield material was eroding in ways NASA did not expect, and they had to completely redesign the re-entry approach. A liquid hydrogen leak during a wet dress rehearsal in February 2026 pushed things even further. So by the time this rocket actually left the ground, it had been over 53 years since humans last flew to the moon. A lot of people had started to wonder if it would ever happen again. That makes what happened next even more incredible. The first image that broke the internet was not even from the flyby itself. It came a few days earlier while the Orion spacecraft was still cruising toward the moon. Commander Reed Wiseman pointed a Nikon D5 camera out the window, dialed the ISO all the way up to 51,200, and captured something Apollo astronauts literally could not have photographed, a complete view of Earth's nightside, illuminated entirely by reflected moonlight. The image is called Hello World. It is haunting. You can see the continent of Africa dominating the frame, city lights scattered across the dark hemisphere like tiny sparks, and glowing bands of aurora wrapping around both poles. Several Apollo missions photographed the full Earth from deep space, but none of them could capture this, a complete nightside view lit entirely by moonlight, showing city lights and auroras at the same time. That was physically impossible with 1960s film. The blue marble was taken in direct sunlight with Kodak film. Hello World was taken in near total darkness with a digital sensor sensitive enough to pick up moonlight bouncing off oceans. The film Apollo used maxed out at ISO 160. Wiseman shot at ISO 51,200. That is a 300-fold increase in light sensitivity, and it shows. And that was just the warm-up. The real show started on April 6th when Orion reached its closest approach to the lunar surface, 4,067 miles up. The crew had a packed schedule. NASA had identified 35 specific geological targets for the crew to photograph, with a full science team monitoring from the Science Evaluation Room at Johnson Space Center in Houston. This was the most advanced real-time science coordination ever attempted during a crewed lunar mission. The first big moment came at 6:41 p.m. Eastern Time, just 3 minutes before Orion disappeared behind the moon. The crew captured what might be the single most breathtaking photograph from the entire mission. It shows the Earth, reduced to a muted blue crescent, slowly sinking behind the cratered lunar horizon. In the foreground, you can see the terraced walls and central peaks of Ohm crater stretching across the moon's surface. NASA is calling this image the Earthset. If that name reminds you of something, it should. This photograph is a deliberate mirror of Apollo 8's legendary Earthrise, the image Bill Anders captured in December 1968 that showed Earth rising above the lunar horizon for the first time. The Artemis II version flips the composition. Instead of Earth rising, it is setting. Instead of hope and ascent, you get a quiet, almost melancholy sense of Earth disappearing behind another world. The White House released it on the morning of April 7th, and it went everywhere. Then, 41 minutes later, the crew emerged from behind the far side of the moon, and they captured their own version of Earthrise. This one was shot with a 400mm telephoto lens, and it shows Earth as a delicate blue-white crescent hovering above the moon's jagged horizon, with cloud systems catching sunlight like brushstrokes. The perspective is fundamentally different from the Apollo 8 version. Bill Anders took his photo from about 60 miles above the surface. The Artemis II crew was at 4,067 miles, so you get a sweeping, wide view of the entire curved lunar limb stretching out below the Earth. It feels bigger, more cosmic. But the image that might end up being the most scientifically significant wasn't even of the moon or Earth, it was of the sun. While Orion was behind the moon, the crew witnessed something unlike anything astronauts have ever experienced: a solar eclipse, viewed from just 4,000 miles above the lunar surface. Now, Apollo astronauts caught brief glimpses of solar eclipses during their missions, but nothing like this. This one lasted nearly 54 minutes of totality, nearly an hour of the moon's massive disk blocking the sun completely, with the solar corona blazing out in every direction as a glowing white halo. During totality, the crew could see Venus as a silver point of light, Mars with its characteristic reddish tint, and Mercury and Saturn also visible simultaneously in the darkness. Victor Glover, the mission pilot, described looking out the window and seeing the moon as this enormous black orb just hanging in front of them. NASA called it one of the longest and most dramatic solar eclipses ever witnessed by humans in space. Think about that for a second. We have watched eclipses from Earth for thousands of years. Ancient civilizations built entire calendars around predicting them. Apollo astronauts caught fleeting glimpses of eclipses in orbit, but nobody had ever experienced nearly an hour of totality from this close to the moon. On Earth, you get 4 minutes if you are lucky. They got almost an hour. That is the difference between glimpsing something and truly studying it. The crew also got one of the best human views ever of the Orientale Basin, a nearly 600 miles wide impact structure that straddles the boundary between the moon's near and far sides. It is 3.8 billion years old, ringed with concentric mountain chains, and features a dark patch of ancient lava that punched through the lunar crust eons ago. The images from 3:41 in the afternoon Eastern Time reveal the basin's structure in detail that orbital cameras just cannot match when you have trained human eyes guiding the composition. And then there is the part of the story that gets personal. Commander Reed Wiseman and the crew proposed names for 2 small craters near the Orientale Basin. One they called Integrity, after the Orion spacecraft call sign. The other they called Carol, after Wiseman's late wife, who passed away from cancer in 2020. The names still need official approval from the International Astronomical Union, but that moment reportedly brought Wiseman to tears. You are floating 4,000 miles above the moon, looking at a landscape no human has ever seen, and you name a piece of it after the person you lost. Space does that to people. Now let's talk about how these images were actually captured, because the technology gap between Artemis II and the Apollo missions is honestly absurd. Apollo astronauts used modified Hasselblad 500 EL cameras loaded with 70mm Kodak Ektachrome film. No viewfinder, no instant review. You pointed the camera, hoped you got the exposure right, and found out weeks later when the film was developed back on Earth. Each film magazine held maybe 150 to 200 frames, and the film ISO was locked between 64 and 160. Across the entire Apollo program, all missions combined, astronauts captured roughly 18,000 photographs. Artemis II has 32 cameras on board. The primary handheld cameras are 2 Nikon D5 DSLR cameras with an ISO range that goes up to 3.2 million. Let me say that again, 3.2 million. That means these cameras can capture usable images in conditions so dark that your eyes can barely see anything. They are paired with an 80 to 400 millimeter telephoto lens for lunar surface detail, and a 14 to 24 millimeter wide angle for those full Earth compositions. The crew also carried a Nikon Z9 mirrorless camera that the astronauts specifically fought to include in the mission kit. Jeremy Hansen, the Canadian Space Agency mission specialist, said they pushed hard to get that specific camera on board. It is serving double duty as both a photography tool and a pathfinder for the HULC camera, the handheld universal lunar camera being developed for when Artemis III astronauts actually walk on the surface. Oh, and they also brought iPhone 17 Pro Max smartphones, to be exact. Wiseman used one to photograph the lunar far side, and when those images hit social media, people lost their minds. An iPhone taking pictures of the moon from behind. 4 modified GoPro cameras are mounted on Orion's solar array wings for exterior shots, and additional GoPros inside the capsule are shooting footage for a National Geographic documentary titled Return to the Moon. The crew actually went through what NASA called astronaut film school back in April 2025 to learn documentary filmmaking techniques. And here's the part that really separates this from Apollo: data transmission. Apollo astronauts had to physically bring their film canisters home. If the capsule sank or the film was damaged during re-entry, those images were gone forever. Artemis II uses something called the O2O Laser Optical Communication System, an infrared laser link that can hit speeds up to 260 megabits per second. At its normal operating rate, that's roughly 36 gigabytes of data in a single 1-hour contact window. So while the crew was still flying past the moon, high-definition images were already arriving at mission control. The full 4K video and the bulk of those thousands of photographs will be retrieved after splashdown on April 10th in the Pacific Ocean off San Diego. Only a small number of images have been publicly released so far. The full archive is going to be something else entirely. So what are scientists actually learning from all of this? More than you might expect. Human eyes, it turns out, are still better than cameras at detecting certain things. The crew reported seeing subtle shades of brown and blue on the lunar surface that were not showing up in their digital photographs. Those color variations reveal differences in mineral composition and surface age that researchers are now eager to study in the full-resolution imagery. The crew also detected 6 meteoroid impact flashes on the moon's darkened surface, tiny bursts of light from space rocks slamming into the regolith at thousands of miles per hour. These are not just pretty light shows. That data feeds directly into hazard assessments for future Artemis surface missions, helping engineers understand how often and how hard the moon gets pelted by debris. If you are planning to build a habitat somewhere, you want to know how often rocks fall from the sky. There are observations of the South Pole Aitken Basin, the largest confirmed impact crater in the entire solar system at 1,550 miles across, along with detailed views of the Orientale Basin's ring structures, are already being fed into geological models of lunar impact history. All of this connects to a bigger goal. Artemis III is targeting a crewed landing near the moon's south pole by early 2028. NASA announced 9 candidate landing regions in October 2024, and those sites are near permanently shadowed craters that may contain water ice. Every observation from the Artemis II flyby helps characterize terrain, lighting, and geological conditions for those unprecedented destinations. If you're finding this interesting, hit subscribe. We're going to be covering every major Artemis update as this program moves toward actually putting boots on the moon. And one more thing worth mentioning about the crew itself, because these 4 people represent something genuinely historic. Victor Glover is a Navy captain who flew FA-18 fighter jets in combat, and later served on Senator John McCain's staff. He piloted SpaceX's first operational Crew Dragon mission in 2020. On this flight, he became the first black person to travel beyond low Earth orbit. Christina Koch is an electrical engineer who worked at research stations in both Antarctica and the Arctic before joining NASA. She already holds the record for the longest single spaceflight by a woman at 328 consecutive days on the International Space Station. And now she is the first woman to fly beyond low Earth orbit. Jeremy Hansen is a Royal Canadian Air Force colonel, a CF-18 fighter pilot with a master's degree in physics, and Artemis II is his very first spaceflight. That makes him arguably the most experienced rookie in space exploration history by mission difficulty. He is also the first Canadian and the first non-American to fly around the moon. Commander Reed Wiseman, a former F-14 Tomcat pilot who previously spent 165 days aboard the space station, is the first person to command a lunar mission since Gene Cernan stepped off the moon's surface in December 1972. The images coming back from Artemis II aren't just photographs, they're proof that we're doing this again. After 53 years of staring at the moon from the ground, humans are finally back out there taking pictures of it up close. This time the cameras are a lot better, the crew looks a lot more like the rest of us, and the best pictures, honestly, probably haven't even been downloaded yet. When that data comes home on April 10th, and NASA starts releasing the full archive in full resolution, we're probably going to need another video. Stay tuned for that.